Okay, there we go. Sorry, I had it all right. I was just punching it into the calculator wrong. Please forgive me. But in any case, so we've got y equals $2,365.48. But remember, this is how much we put into the CD. Are we done? Not quite. So now we've got to take this information with what we have from equation 1 to see that x is equal to 8,000 minus this much. What a very specific amount of money Kent invested, wouldn't you agree? So now we have 8,000 minus 2365.48, and that is 5,000. So the amount we put into the stock fund is $5,634.52. Okay, so now I'm going to show you how this is very similar to what we do with example 5. So, example 5, Aaron is preparing 15 liters of an 18% saline solution. Aaron has an unlimited supply of saline solutions with concentrations of 40% and 10%. Find the amount of each of these concentrations that should be mixed together to get the desired 15 liters of an 18% solution. Okay, so like example 3, here we're going to have two equations. The first equation describes the amount, in this case, of liquid, but in other cases you may have like bags of concrete. I think it's just a lot of liquid, but amount of stuff. And then 2 describes the purity. Okay, so if I've got something that's 100% pure, then you'd have 1, because you're going to want the decimal version of the percent, not the percent itself, right? So here, I like to say I have my x, y, and z. X is one that I have, so I've got, let's see, this is liters of my 40%, liters of my 10%, and then liters of my wanted solution, in this case, is 18%. So, to go from here, very similar to what we did in example 3, we have 1, that x plus y has to equal z. So now, when you want purity, 2 is just going to be the decimal percent of the x, so 0.4x plus 0.1y equals 0.18z, because this, I have 40% pure, 10% pure, and I want a desired 18% pure. So really, you're just going to take x plus y plus z, tack on their purity, their percents, and that's it. Now I'm going to go through and use my numbers. So with equation 1, find the amount of each. If I know that I have 15 liters of the 18% solution, right? So x plus y is equal to 15. So now for example 2, I've got 0.4x plus 0.1y is equal to 0.18 times 15. But remember now, we haven't worked our way up to 2 variables yet. So what we're going to do is similar to what we did above. I'm going to say, okay, well then x is equal to 15 minus y. So now I'm going to throw in or substitute in 15 minus y for x. So I really have 0.4 times 15 minus y plus 0.1y equals, let's see, what is 0.18 times 15 is 2.7. So distribute the 0.4. 0.4 times 15 is 6. So I've got 6 minus 0.4y plus 0.1y equals 2.7y. Excuse me, this is 2.7. I got a little y happy there. So combining like terms, I'm going to subtract the 6 over. So that's going to give a negative, what, 4.3? So 2.7 minus 6. Oh, excuse me, negative 3.3. Couldn't math there for a second. Now, negative 0.4 plus 0.1 is a negative 0.3. Why? So doing that division, we get that y is equal to 11. So for the 40%, or excuse me, the 10%, so the 10%, we are using 11 liters. So then if I want to know how much of the 40%, that's 15 minus 11, so that is 4 liters. Now, here's where that last step of the first page we talked about interpreting the results. I want you to think, if I have a 40% and I've got a 10%, does it make sense that we're using way more of the 10% than the 40%? Hopefully it should, right? Because basically what we're doing is we're diluting the 40% solution to get the desired 18%. So we're going to use a lot more of the 10 so that we can dilute the 40. All right, so if you have questions, please write them down, shoot me an email, go to MathCats, anything you can to get the help.